Good morning, student. The next topic is complex number, and today we will discuss about the square root of a complex number and then a polar form of a complex number. So let us consider how we will find the square root of a complex number. Square root of a complex number. Let a plus iota be the given complex number and the square root of this a plus iota be let x plus iota y. What we have given? Well, we have given a plus iota b कोई complex number है और let us suppose इसका जो square root है वो x plus iota y है. Then root of a plus iota b will be equals to x plus iota y. Now squaring on both sides, दोनों तरफ अगर अपन स्क्वायर करते हैं तो दोनों तरफ स्क्वायर करने पर a plus iota b will be equals to x plus iota y का होल स्क्वायर. That is x square minus plus of iota square y square plus 2 iota xy. Now iota square is equals to minus 1, so x square minus y square plus 2xy into of iota. So this is the real part and this is the imaginary part. So finally a plus iota b is equals to x square minus y square plus 2xy into iota. Now we know that on comparing on both sides, on comparing the real part of z and imaginary part of z, we will get x square minus y square is equals to a and two xy is equals to b. देखिए real part is here a, right hand side में x square minus y square, imaginary part is b and here imaginary part and right hand side is 2xy. So x square minus y square is equals to a, let the equation number second, and 2xy is equals to b, the equation number third. Now we know that x square plus y square whole square is equals to it will be equals to x square plus y whole square is equals to x square minus y square का whole square plus 4xy. So it will be equals to x square plus y square whole square will be equals to x square minus y square whole square, that is a square plus 4xy 4x square y square, that is 2xy का whole square, so it can be written as b square. So x square plus y square will be equals to root of a square plus b square. This is the equation number 4. Now by equation number first, second and 4, on adding x square minus y square is equals to a and x square plus y square is equals to root of a square plus b square. On adding both sides, so 2x square will be equals to root of a square plus b square plus of a. Implies that x will be equals to 1 by 2 root of a square plus b square plus of a whole root. This is the value of y. Similarly, the putting this values of x in x square minus y square, then y will be equals to 1 by 2 root of a square plus b square minus of a whole root. Implies that the square root of given complex number will be equals to root of a plus iota b will be equals to x plus iota y, that is 1 by 2 root a square plus b square plus of a whole root plus iota 1 by 2 into root of a square plus b square minus of a whole root. This is the square root of the given complex number. So in this way, we can find the square root of the given complex number. Please pause the video, note down. This is the derivation. You can learn direct formula. That is real part square plus imaginary part square. A square plus b square means mod of z plus real part of z 1 by 2, and here square root of 1 by 2 root a square plus b square minus a, that is mod of z minus of a. So this is the square root of any complex number. Now we will do some application part. So डायरेक्ट स्टैंडर्ड फॉर्म में फॉर्मूले को कैसे याद करेंगे वो भी मैं आपको बताता हूँ. So the square root of any complex number be written as, so the square root of given complex number z can be written, square root will be equals to mod of z plus real part of z by 2 whole root plus iota into mod of z minus real part of z whole upon 2 and whole root. This is the square root of a complex number. This is the square root of a complex number, and this is the when mod of z is mod of this formula is applicable when if imaginary part of z is greater than 0, and if imaginary part is less than 0, then minus iota will be the square root of the given complex. So let us do one application. Let us pose first question. If we have to find the square root of 7 minus 24 iota, then let the square root of this will be x plus iota y. Then squaring on both sides, so 7 minus 24 iota will be equals to x square minus y square plus 2xy into iota. So on comparing real part and imaginary part, x square minus y square barabar 7 and 2xy is equals to minus of 24. So these are the two relations. Now we know that x square plus y square whole square will be equals to x square minus y square whole square plus of 2xy whole square. This is the x square plus y x square plus y square x square plus y square whole square x square minus y square plus 2xy whole square. Okay. So x square plus y square whole square will be x square minus y square 7. So this is the 49, and 2xy is equals to minus 24. Minus 24 ka 576 implies that there are the two relations. One is x square plus y square will be square root of 625, that is 25. So let this equation number third. Now by equation number first and third, x square minus y square is equals to 7 and x square plus y square is equals to 25. On adding these two, so 2x square is equals to 32, x square is equals to 16, so x will be square root of 4. The substituting value of x in equation number first, so x की वैल्यू अगर अपन प्लस माइनस 4 पुट अप करते हैं तो आपके पास वैल्यू आएगी x की जगह 4, तो 16 माइनस ऑफ y स्क्वायर इज इक्वल्स टू 7 minus y square is equals to 7 minus 16. So y square is equals to 9. So y barabar plus minus 3. So the square root of 7 minus 24 will be equals to plus minus 4 plus 3 iota. This is the square root of given complex number. So in this way we can find the square root of complex number. This is the whole process. You can solve directly by the formula. So now we will apply the formula. डायरेक्ट फॉर्मूले को बेस मान करके भी आप सोल्व कर सकते हैं. मैंने आपको कंप्लीट प्रोसेस बताया कि किसी भी कॉम्प्लेक्स नंबर का स्क्वायर रूट कैसे निकालेंगे. अगर आपको फॉर्मूला अप्लाई करना है तो सेकेंड मेथड बता रहा हूँ. देखिए, गिवन z was 7 minus 24 iota. So सबसे पहले mod z निकालेंगे. mod z क्या होता है? रियल पार्ट ऑफ z स्क्वायर प्लस इमेजिनरी पार्ट ऑफ z square. So 7 real part 7 का square plus 24 का square, that is 49 plus 576, that is root of 625, that is plus minus 25. This is the plus minus 25. Now this is this and real part of z is your 24. So square root of 7 minus 24 iota will be equals to plus minus square root of mod z. Mod z is 25 plus real part of z कितना है आपका? Real part of z is 7. Real part of z is 7. So 7 plus 25 divided by 2 plus iota 25 minus real part upon 2 whole square root. This will be the, so 25 plus 7 32, 32 divided by 2 16, 16 का square root plus minus 4 plus iota 25 minus 7 will be equals to 18, 18 by 2, that is 9, square root of 9 is so plus 4 plus 3 minus 4 plus 3 iota. This is the direct formula we can apply. So please pause the video and note down. Now the next topic is to find the polar form of a complex number. To find the polar form of a complex number. So first, in this case, to find the polar form of a complex number, first the representation of a complex number in. So second, representation of a complex number in a complex plane or ordained plane or Gaussian plane. These are the three names. Representation of a complex number in complex plane, ordained plane or Gaussian plane. So let z is equals to a plus iota be the given complex number. Then this complex number a plus iota b can be expressed as a comma b in the ordered pair form, where a is the real part of complex number and b be the imaginary part of complex number. Now if we have to represent this complex number in the complex plane, then let us suppose this is the x o x days and this is the y o y days. This is the real axis and this is the imaginary axis. Now to represent this complex number in this complex plane, if any complex number is purely real, that is the purely real means is say imaginary part b will be equals to 0, so z will be equals to a, and if a is equals to 0, then z will be equals to iota b, purely imaginary. So a will lies on this x dash axis. If a is positive, then in positive direction, and if a is negative, then negative direction. That's why this is known as real axis. And if z is equals to iota b, then b positive, then it will be lies on oy, and if b is negative, then it will lies on y dash. That's why it is known as imaginary axis. Otherwise, if a and b having some numerical values, then if a and b both are positive, then it will be the first quadrant. Then if first negative real part is both are positive plus a plus b, then in first quadrant, minus a plus b then second, minus a minus b then third, and plus a minus of b then fourth quadrant. So our complex number is z is equals to a plus iota b, where real part and imaginary part both are positive. So it will lies in the first quadrant. So let z barabar a plus iota b is represented by any point p having coordinate a comma b. Then to draw, on drawing a perpendicular on real axis, and if it is meeting at a, then this OM will be equals to real part of z is equals to a, and this PM will be equals to imaginary part of z, that is equals to b. So this is your A and this is your B. Now if we join this OP, then OP will be equals to square root of real part of z whole square plus imaginary part of z whole square. So real part of z square plus imaginary part of z square, this will be equals to root of a square plus b square, which is equals to mod of z. So this OP will represent by mod of z. So for the given complex number a plus iota b, this complex number can be written in ordered pair form a comma b, and this a comma b will represent always a point p. So let the point be a comma b, then this OM will be real part of z, then PM will be imaginary part of z. Then by the Pythagoras theorem, basically OP will be equals to real part of z square, that is a square plus b square. Since real part of z square plus imaginary part of z square whole root is represented by mod of z, so this OP will be mod of z. So now in this complex plane, if OP is the revolving line, then the inclination of this OP with the initial axis is, let us suppose, theta. Then this theta is known as theta. If theta is less than pi, greater than minus pi, then this theta is known as its principal argument. And this theta will always the inclination of revolving line with initial axis. So if the complex number is lies in the different plane, then this theta will be different. So in first quadrant, let us suppose this theta, then theta can be calculated always, then theta is equals to imaginary part of z upon real part of z. So then theta will be equals to real part of z is your absolute b upon a. So theta will be equals to tan inverse of b upon a absolute. So this theta is known as the principal argument of this complex number. So for the given complex number, if we have to find the polar form, then the polar form of this complex number is given by then z is equals to mod z cos theta plus iota sin theta is known as a polar form of a given complex number z is equals to a plus iota b, where mod z is equals to real part of z whole square plus imaginary part of z whole square, and theta is equals to tan inverse of imaginary part of z upon real part of z absolute. So, to find the polar form of any complex number z is equals to a plus iota b, z will be given by mod z cos theta plus iota sin theta, where mod z will be real part of z whole square plus imaginary part z whole square ka whole square root, and theta will be given by tan inverse imaginary part upon real part of z. Now, if the complex number lies in the various quadrant, then how we will write the argument of a complex number? So, if any complex number in the first quadrant, then we will write the argument as, so let us suppose z is equals to a plus iota b, then in first quadrant let the point P is representing by the point A comma B, then this theta be the principal argument, and let theta be the alpha, then mod of z will be real part of z square plus imaginary part of z square, that is root of a square plus b square, and theta will be equals to alpha will be equals to tan inverse of imaginary part of z upon real part of z absolute. If the complex number z is equals to a minus iota b, minus of a plus iota b, then in ordered pair form this will be equals to minus a comma b. So in two dimension space complex plane, this point B, let us suppose this point Q minus a comma b, then this is equals to minus a, this will be b, and the theta will be given by tan inverse of imaginary part of z upon real part of z absolute, and the principal argument will be alpha. So alpha will be equals to pi minus of theta, and mod of z will be equals to real part of z, that is a square plus b square. So in the first quadrant, argument theta will be equals to alpha, where alpha and theta both will be given by tan inverse imaginary part upon real part. And if the complex number is lies in the second quadrant, then theta will be calculated by tan inverse imaginary part upon real part, and where theta is the inclination of this line OP with the negative real axis, and alpha will be given by pi minus theta, because this complete angle will be equals to pi, and inclination of this revolving line OP with the initial axis will be its principal argument. So principal argument will be, let us suppose alpha, then alpha will be equals to pi minus theta. Similarly, we will discuss in the third and fourth quadrant. So let us, if the complex number lies in the third quadrant, then how we will find the principal argument. So let given complex number be minus a minus iota b, then its ordered pair form minus a comma b. So complex number will lies, let us suppose, represent by the point r minus a comma minus b. Then on drawing perpendicular from r to that axis, then this will be equals to theta. So this is your minus a, this is minus b. Then tan theta will be given by imaginary part of z upon real part of z absolute. So finally theta will be equals to tan inverse of b upon minus b upon minus a absolute. Now the principal argument, let us suppose, is alpha, then alpha will be equals to pi plus theta, or pi minus theta of minus. So दो तरीके से निकाल सकते हैं. अगर हम पॉजिटिव डायरेक्शन में निकालेंगे तो यहाँ तक पाई प्लस थीटा, और अगर नेगेटिव डायरेक्शन में निकालेंगे तो दिस इज योर माइनस पाई में से अपने को पाई माइनस थीटा का नेगेटिव डायरेक्शन. सो दिस इज द argument of a complex number which lies in the third quadrant. Now in fourth quadrant, very simple. If the complex number is a minus iota b, then in ordered pair form a comma minus b. So in fourth quadrant, let us suppose the point is represented by s, a comma minus b. Then on drawing, perpendicular from that point to real axis. So this will be equals to theta. This is your positive a. This is minus b. Then theta will be given by tan inverse of imaginary part of z upon real part of z absolute. Now theta will be equals to minus of alpha, because the inclination of revolving line with positive direction will be equals to minus alpha. So in this way we can find the argument and modulus of a complex number in different quadrants.